looking at our test for continuity. We can actually test. We don't have to just guess by looking at a graph or trying to figure out what our calculator is telling us. But no, we have a test for it, and it has to meet three qualifications in order to be continuous. First of all, the function has to be defined at whatever that value. Notice we're looking at a function, and we're looking at, is it continuous at this certain value of x? We're checking for a certain value. Is it continuous at this value? Does it have a hole right there? Is it infinitely discontinuous right there? Is it jumping? Who knows, right? We're trying to figure out, is it continuous? And so it has to meet these three conditions. First of all, it has to actually be defined at that. That's where we're checking to see, was it an infinite discontinuity, or is it removable? Well, if it's not even defined at that value, then it's not going to be continuous. We also have to check to make sure it's approaching the same value from both sides. And so we're going to have to find the limit as x approaches this value in both directions. We're going to have to see, are we approaching the same value? And finally, that value we're approaching should be the output that we got back in that first thing, back in that first check. When we plug in that value for c, well, we get something out, and that should be the value that it's approaching from both sides. And so we have to meet all three of these qualifications to be continuous. So looking at this, we have this function here, and we want to know, is it continuous at x equals 2? And yes, we want to use our continuity test. And the three things we need to do is we need to make sure it exists, we need to make sure that it's approaching the same value from both sides, and finally, is that value it's approaching from both sides the same value we got out in the first step? So first of all, does f of 2 exist? Well, we're going to plug in 2 for x. F of 2 means we're going to plug in 2 for x. When we do that, we have 2 times 4 minus 6 minus 1. 8 minus 6 minus 1, that would give us 1. When we put in a 2, we got out a 1. So first of all, does it exist? Yes, and what we got out was a 1. So now we want to find the limit as x approaches 2 for our function. So I'm going to put 2 right smack in the middle. We know when we put in a 2, we got out a 1, but we're not going to worry about that right now. We want to see, where does it approach in both directions? What is it getting close to in both directions? Well, as we get closer to 2 from beneath 2, we're looking at like 1.999, 1.99, 1.9. So we're getting a little bit closer and closer to 2. It's really, really close to 2. Yes, we know it rounds to 2, but it's not quite 2. In the other direction, we're looking at 2.001, 2.01, 2.1. Notice how these are the same distance away from 2, but just in different directions. This is greater than 2, this is less than 2. So we want to check this. It helps to have a calculator. Here are some calculator tips. In order to do this a little bit quicker, I would type in that function right there exactly as you see it. 2x squared minus 3x minus 1. Notice, I'll pull this up a little bit closer so that you can see it. Here, I've typed it in. And if I hit enter, yes, it gives me out some value right now. Don't worry about that right now. What I'm going to do is I'm going to first take that first value, 1.9, and store it for x. And so notice it's giving me 1.9. If I go back and recall my former entry, second enter again, pulls up that polynomial expression. I hit enter, and it has now plugged that value of 1.9 that was stored for x in for x. When we put in a 1.9, we just got out a 0.52. So I'm going to write that up here. 1.9 gives me a I can continue with that same process. 1.99, store it for x. Second enter again, pulls up that polynomial, that expression right there. 1.99 store for x gives me 0.9502. 0.9502. Gonna do it one more time. 1.999, store it for x. Second enter twice, pulls up that, and 1.999 gives me 0.995. Notice that in this direction we're getting closer and closer to that value of 1. 0.52, 0.95, 0.99, we're getting close to 1. This is approaching 1 from this direction. I'm going to do the same process in this direction. Notice this is getting closer and closer to 1 in this direction. So what is the limit? As we get closer and closer to 2, the limit is 1. It's what we were hoping for because that was our output earlier. And yes, we can see it is getting closer to 1 in both directions. So the limit did equal the output. And so this is continuous at x equals 2. Those are the three things we have to do. That is our continuity test. And so yes, this is continuous.